When you look up at the night sky, you're seeing just a fraction of the observable universe, a vast cosmic ocean stretching over 93 billion light-years across. But here's the mind-bending question. What lies beyond it? Does the universe go on forever? Is there a boundary, a wall, an edge? Or could there be something completely different? Another universe, another dimension, another everything? Let's begin by understanding what we mean when we say the universe. In cosmology, the observable universe is the region of space from which light has had time to reach us since the Big Bang, about 13.8 billion years ago. But because space itself has been expanding, this horizon extends far beyond 13.8 billion light-years. In fact, due to cosmic inflation, it's closer to 46.5 billion light-years in every direction. But the observable universe is not the whole universe. It's just the part we can see. Beyond that horizon, light hasn't had enough time to reach us yet. But that doesn't mean there's nothing there. Most cosmologists believe the universe continues far beyond what we can observe, potentially infinitely. But infinite in what way? There are a few possibilities. Infinite and unbounded space. In this scenario, space doesn't have an edge. No boundary, no wall, no outside. It just goes on forever, like the surface of a balloon, but in 3 dimensions. You can travel endlessly and never encounter a limit. This aligns with the Hall cosmological principle, which assumes that the universe is homogeneous and isotropic on large scales, the same everywhere and in all directions. But if the universe is truly infinite, then strange consequences follow. In an infinite space with a finite number of particle configurations, every possible arrangement of matter must occur somewhere, including exact duplicates of you, me, and even this video. Somewhere, in a region so distant it's forever unreachable, an identical Earth may exist. Maybe infinite Earths. This is the idea of the cosmic doppelganger, and it arises not from science fiction, but from mathematics, curved and finite space. Alternatively, the universe might be finite but unbounded, like the surface of a 4D hypersphere. In this case, space loops back on itself. If you traveled in a straight line long enough, you could, in theory, return to your starting point, though expansion would make this practically impossible. Evidence from the cosmic microwave background, CMB, suggests that space is very close to flat, but it doesn't completely rule out subtle curvature on scales larger than we can observe. Multiverse beyond the boundary. Here's where things get wild. According to inflationary cosmology, our universe may be just one bubble in a vast cosmic foam, a multiverse. During eternal inflation, quantum fluctuations give rise to countless bubble universes, each with different laws of physics, dimensions, and initial conditions. Our bubble expanded and cooled in just the right way to form stars, galaxies, and life. But other bubbles might be completely lifeless, or so alien that we can't even imagine them. In this view, beyond the universe doesn't mean empty space. It means other universes. Entirely separate realities, disconnected from ours by distance, dimensions, or causality. These bubble universes could be so far apart that no signal, no light, no gravity could ever bridge the gap. Yet their existence is mathematically implied by inflation models and supported by string theory's landscape of solutions, each corresponding to a different possible universe. Higher dimensions. Some theories, especially in string theory and brain cosmology, suggest that our entire universe might be a 3-dimensional brain floating in a higher dimensional space called the bulk. In this picture, multiple brains, each a universe in itself, could exist side by side in higher dimensions, occasionally colliding or interacting. The Big Bang, in fact, might have been the result of such a collision, a burst of energy as two brains touched. If true, then beyond the universe literally means outside our dimensions, a place where different rules apply. Some even speculate that gravity is weaker than other forces because it leaks into these extra dimensions. Beyond physics? Perhaps the biggest mystery isn't what lies beyond space, but whether the question itself makes sense. Space and time might be emergent phenomena, arising from quantum entanglement or some deeper, pre-geometric reality. In that case, asking what's beyond the universe would be like asking what's north of the North Pole, a question that breaks down at a fundamental level. Yet the human mind resists limits. We are explorers, thinkers, creators. When we hit a wall, we build a door. And that's why the idea of beyond the universe captures our imagination. What lies beyond may not be reachable. It may not be knowable. But the pursuit of that question leads us to better theories, deeper science, and greater wonder. At Infinity Beyond, we're not just asking what's out there. We're asking why we care. Because in every question about the edge of the cosmos is also a question about the edge of our understanding. In our next episode, we'll turn inward again, exploring how time, space, and existence itself may arise from nothing. What does nothing really mean? And can something truly emerge from it? Subscribe to Eternity Beyond, and let's continue stretching the limits of space, mind, and imagination.